Welcome, everyone. Good morning. And on behalf of AGMA and Gear Technology, I'm honored to present another in a series of educational webinars for the gear industry. I'm Gary Jesh, your moderator for this webinar, and it's always great to have this large audience for an important technology like seal manufacturing. Before we get started, we want everyone here to know that we will be answering questions at the end of the presentation. So feel free to use that questions tab in your GoToWebinar control panel. We prefer you stick to the questions tab and not the chat tab, if you would. We will get to as many as we can by the end of the presentation itself. And additionally, we are recording this presentation and we'll be making it available to you as an on-demand video within a day. So here's some info about today's program. Leaking seals mean teardowns and overhauls of critical equipment, usually at the worst possible times, no matter what industry you're in. They can have serious consequences in every area from aerospace to automotive and beyond. Learn how to overcome these challenges from an expert in the field in this webinar, co-sponsored by Gear Technology and Freudenberg NOK. This 1-hour webinar addresses leaking seals, friction, and other concerns that you might have with your own operations. We'll take a look at the huge line of Freudenberg NOK seal products, along with engineering data that's relevant and helpful. So let's introduce our Freudenberg seal specialist and today's presenter, Darren Hull, Sales Application Engineer in North America. Welcome, Darren. How are you?
I'm great, Gary. Thank you for that kind introduction and welcome everyone to today's webinar. I'm looking forward to having this discussion with you about Freudenberg NOK radial shaft seals, the Simmerring.
Well, it's really great to have you here today, Darren. Tell us a little bit about yourself and your background.
Yeah, I've been with the company for 27 years and my background is in mechanical engineering. So I am currently the sales application engineering lead for North America for Freudenberg NOK on the general industry side of our business, which is basically the non-automotive side of our business. But over my career, I've held several technical positions from product design to application engineering and also even with account management.
And so you have degrees in mechanical engineering?
I do. I have a mechanical engineering degree and also an MBA.
Excellent. And what about your free time? I know we're catching you here at work today, but what kind of things do you like to do in your free time?
Well, my free time, I really enjoy spending it. My summers, my fun job is actually at a local drag strip here in Norwalk, Summit Motorsports Park. It is a national award-winning and NHRA sanctioned drag race strip, and I work many of the larger events they have over the summer. I do not race. I don't have the stomach or the pocketbook for that, but I live vicariously through the racers there. And I do a lot of just general operations, traffic director or direction, crowd direction, things of that nature. But I do enjoy, horsepower and things like that when I'm not here at work.
Yeah, the roar of the engine of those dragsters is something else. That's a big thing for me too. I really enjoy it, but I end up watching them from my couch. All
For
right,
sure.
Darren. Yeah, well, we're looking forward to hearing what you have to say here today. Why don't we go ahead and dive right in?
Thanks, Gary. I am too. So yeah, why don't we just get started and I'll head right into it and we'll talk about several topics here today. We'll touch on some market trends and drivers and how our shaft seals impact that and how you can leverage the technology from our shaft seals to benefit you. But what presentation wouldn't be complete without a little bit of discussion about the company and our history. So we'll touch on that briefly. But want to give you an idea where we started and how we've come up to this point. So Freudenberg has been around for 175 years. This year is actually, we do celebrate our 175th year. And interestingly, Freudenberg started out as a leather tannery in Germany. So they were making, tents, shoes, saddles, buggy whips, things of that nature. And because of that, they always had a lot of excess rubber scrap material. And some of your first seals for wagon wheel axle seals were actually those scraps of leather being packed, being wedged, being jammed into those areas, nooks and crannies to keep whatever they were using to lubricate it, whether it was lard, whether it was early greases, things like that. That was the beginning of rotary shaft sealing, and they were doing it with leather, leather packings, leather strips. So so our genesis has been as a materials company, and we'll talk a little bit about how that genesis as a leather manufacturer led us into radial shaft seals and actually polymer and rubber radial shaft seals, right? So our sales last year were about $2.8 billion. We have about a little over 13,000 employees globally. We are a global company. We are located in Asia, Europe, North America. So we make quite a few seals, small round seals. That's our business. We make over 5 billion seals a year, which translates to maybe about 20 million or so a day. So we make quite a few, quite a lot of different shapes, configurations, and materials. And we are one of the largest rubber users in the world outside of the tire manufacturers and hose manufacturers. So with us being a materials background, we have over 1,400 specific material compounds and specific recipes and formulations. We compound and recipe all of our own materials, we mix all of our own materials, and we mold all of our own materials. And in those 1,400 formulations, we use in combination here and there a difference of 5,000 different raw material compounds and different ingredients to make these different mixtures and recipes. And we are a German engineering company, and we pride ourselves in always looking into innovations and always becoming better with our material and our product innovations. And with that, little over 4% of our revenue annually is reinvested into our research and development activities. And it's not just to do research and development, but we translate that into actual new products and new sales. And over the past 5 to 7 years, roughly a third of our business has been through the introduction of new materials and new products. So when we talk about Freudenberg NOK, we are a joint venture from global players. Freudenberg Sealing Technologies, which is our parent company based in Germany, and then we're partnered with NOK of Japan, that is located in Japan, in Tokyo, Japan. For many, many years, Freudenberg and NOK collaborated, worked in partnership together in both the European and the Asian arena. But when they came to North America, they would actually be competitors. They would be importing their products, be competing against each other. So finally in 1989, what happened was they said, this is silly, why are we doing this? They formed a Freudenberg NOK joint venture here in the US. It's based in Plymouth, Michigan. And there's a reason that's why it's based in Plymouth, Michigan, because their first target obviously was the automotive industry. At that point, it was heavily automotive, but since that point in time, we are now probably 60-40% automotive and general industry. And within the Freudenberg NOK Sealing Technologies company, we do also have a sourcing brand, which is called Dishtomatic, which some of you may recognize. That is a brand of Freudenberg NOK, but all of these entities fall underneath the Freudenberg umbrella. So let's talk about shaft sealing and the original oil seal, the Simmerring. There's a reason for why we call it that, but its genesis again was these rubber wafers, or I'm sorry, these leather wafers, right? We had these leather scraps. We needed to create some better technology, a better functioning seal that would be seal on a rotating shaft. And what happened in 1929, an engineer with Freudenberg, Walter Simmer, used a sealing lip that was made of leather, and he clamped it between two metals and put a little garter spring on it to provide some clamping load. And that was the birth of the radial shaft seal, which became known as the Simmerring after our engineer Walter Simmer. It was the original. The name Simmerring is a registered trademark of Freudenberg, stands for the highest quality, and is highly recognized, especially within Europe. Now, being a materials company, we have evolved. We have evolved from that 1929 use of leather, and we've evolved that into the use of polymers and rubbers for various applications, and we'll talk about that a little bit further. Interestingly enough, we still have a few of our part numbers that still require, and the customers require, and we actually use leather for some of those seals. So we do actually still produce a few, very, very few leather seals. So based upon our background in the sealing world, we have many different engineering solutions for gearboxes. We're going to be talking about the ones that are starred here today. We'll be talking about the Simmerring, and then variations of that, which would be the MSS, our modular sealing solution Simmerring, and our PSS, our premium sign seal Simmerring. Those are dynamic. We have a rotating surface running against those seals, and the sealing is provided at that running surface. But we also have other sealing technologies as well, including gaskets, which would be considered static, as well as O-rings, and then some other variations of shaft seals, which would be a cassette seal. But we're going to be talking primarily about the ones here that are starred. So let's talk a little bit about what we see. We performed some surveys and some feedback that we've received from the gearbox market. What we're seeing is trends coming back. We're seeing this trend in every industry, whether it's in gearboxes, whether it's in hydraulic pumps and motors, anything that has a spinning rote, even in e-mobility, e-motors, e-drivetrain. What we're seeing is that the shaft speeds and the temperatures are not ever going down. Everyone wants to run faster and they want to run hotter. And then what happens is that as you run faster, you get more friction, you're going to run hotter. So then you have to look at some complex lubricants and contaminants and worry about contaminants and how they react with the fluid. So this is all being driven by the need for higher power density. We're also seeing some increased eccentricities on the shafts out in the field. We see increased dynamic cycling of the shafts going one direction and then the other, bidirectionally, unsteady movement. Not just steady state running, turn it on and having it run and run. We see different variations of the function. We have different RPMs for different time frames, slowing down to 0, higher accelerations up to their peak speeds. So we're seeing a lot of different types of speed regimes and temperature regimes out there. So as a result, as I mentioned, the development of complex lubricants in order to have higher performance, and those lubricants can create some internal types of contamination, as well as we're always fighting against the external contamination as well. What we're seeing, especially in the world of e-motors, is the need for better efficiency, reduced force on the shaft, reduced load on the system. And if we can reduce the force on the shaft, that really helps us, because friction and power loss and heat generation because of friction, those are all enemies of polymers and rubber, the #1 enemy, in fact. And whenever we can minimize that, that will greatly add to the longevity of the seal. And then everyone wants to have longer warranty periods, extended service intervals. With nitrile NBR materials, the seal expectations is 10,000 hours. For FKM, which is a premium material, higher temperature resistance, higher fluid resistance, chemical resistance, we're seeing greater than 20,000 hours as an expectation for the service period. So how can we help you with that? Well, we've been in it, as we demonstrated, we've been in this business, we've been in the radio shaft business for a long, long time, in the materials business for even longer. So, and because of that, we do have a complete understanding of that tribological system. What is that? Well, the tribological system is really the seal lip that you can see at the arrow, where it contacts the shaft, and how that lubricant interacts with the seal and the shaft during rotation, right? So that's the whole crux of where the sealing takes place, and that's where we got to concentrate our understanding. We do actually have a program with our sister company, Kluber Lubrication, who is a Freudenberg company, a lube and seal program where we interact and we work collectively and collaboratively with them in order to understand how their lubricants interact with our different rubbers and how that affects the performance of our shaft seals. We can provide you with supplier design support. We can help you define the size and the design and ensure the compatibility of that design with your application conditions, both the lubricant, the temperatures, the pressures, anything like that. We definitely have a vast amount of knowledge and support engineering and technical functions for that. We are vertically integrated supply chain within our company. As I mentioned, we formulate all of our own compound recipes. So we are mixing them, we are molding them, we have an intimate understanding of what those are, and that is the key to our success, is definitely within our rubber materials. So what I wanted to do is show you a little bit of how does a seal work? We're talking about the tribological system. It's very important where that seal lip contacts the shaft, how it interacts with the lubricant. So what has to happen? There has to be some type of a pumping action that takes place at that seal lip. And it can't be just pumping it through from the oil side or the lubricant side out to the air or out to the exterior, because then that would produce a leak, and that's definitely what we're trying to prevent. So what we need to do is, what we're doing is we're kind of blowing up this area here where the seal lip contacts the shaft. And what we find is that this is blown up, this is magnified. It's about maybe at most a half millimeter wide. That's the contact band of a brand new seal. And what we're trying to do is we have pockets, we call them microasperities. They're really small pockets of contact with the shaft and non-contact with the shaft of the rubber. So the rubber texture interacts with the shaft texture, and then when the shaft spins, it creates opening and closings of those, and it creates a pumping mechanism. And it's a one-way pump, actually. It'll pull the fluid, it'll bring fluid underneath the lip, and then it will evacuate it out into the oil side. So what does that do? Well, number one, it prevents leakage, which is what we want. Number two is that oil actually takes a lot of the heat, or some of the heat that's generated at that seal lip interface, transfers it away from the seal lip, which is a very, very important function of the lubricant as well. So the design of the seal lip, the material used, how we integrate that spring and create lip loads, it's all very integral to how we create this one-way pump. And this actually does happen. So what I'm going to show this video here is what you're looking at is NOK at one point built themselves a glass shaft, placed a camera on the center line, and directed it upward at what you're looking at right now is the contact band of a radial shaft seal. That is the contact band. It is blown up in width. Obviously, that's greater than 0.5 here showing, but that's basically 0.5 millimeter. And we can see already that there's areas, we have pockets of contact, we have pockets of non-contact. But what's key is we don't have any pockets that go from one side to the other, creating a leak path. So once I start this video, what you'll see on the left-hand side, you'll see it become all black. That's we have fluid or oil being flooded on the left-hand side. You'll see that it statically will not go through to the right-hand side. Then the shaft will begin to spin, and over time you'll see this area here, this area right in here, will start to get lighter in color because the oil is being pumped back away. So let's start the video. Okay, we have oil coming in, flooding. Now we have the shaft rotating. Now let's take a look in this area right in here along the contact band, and we will start to see that that area will start to lighten. We're seeing it right now. We're seeing the oil starting to be pumped back to the oil side, but yet we're not pumping it completely dry. We still need some of that oil to be contained underneath for lubrication, but it's being replenished. It's being pulled in and being replenished over the course of the rotations and the operation of the seal. So that's the area that we've got to maintain. We've got to make sure we have some pumping mechanism going on with our seals, and it's extremely important to keep the friction down, and it's important to keep heat from building up in that area. We try to minimize that. So what are the impact of the radial shaft seals on your system then? Let's first talk about this area over here on the right. When we talk about there's a lot of specific heat power going on at the Simmerring lip and the sealing gap, it is significant. Now, if we compare it to, we all had a hot plate. If we went to college, we had a hot plate. We use it. We had it in our room. We were going to heat up things to eat. The specific heat power of a heat plate, 2,000 watt diameter of 18 centimeters is about 8 watts per cubic or per centimeter squared. Within the Simmerring sealing gap, which is significantly smaller, it is significantly higher. It's up to 220 watts per square centimeter. So what we found in the world of gearboxes is seals are a leading cause of gearbox leakage and warranty claims. And that just stands to reason. If the seal is not able to compensate the operating conditions, or if it's damaged on installation and we have leakage, it can't compensate for that. So it becomes the #1 suspect of the problem with the gearbox. Friction is a big problem of that. Heat generation is the #1 enemy of any polymer or rubber, because when you have friction, you increase heat. When you increase heat, you increase the degradation of everything. You increase the degradation of the rubber, you increase the degradation of the oil, and then you impact the seal lifespan and hence the system lifespan. How important is minimizing heat? There was a Austrian physicist at one point that won a Nobel Prize for his work in actually the oxidation of fluids. And it actually applies to polymers as well. And his rule of thumb basically is that for every 10 degrees Celsius increase in heat that the seal lip sees, you can potentially reduce the seal life and the rubber life by 50%. So it doesn't take a lot of increase in heat to have a really big impact on the life of your seal. So it leads to seal wear, which can also lead to shaft wear. So it just degrades, heat just degrades the whole system. And wherever we can minimize it, we're never going to totally get away from it, but wherever we can minimize it, it improves the lifetime of the seal significantly. So why do we choose our radial shaft seals? Well, we've done benchmark testing within our company against our competitors. And while, yes, we have our specific formulations and all cross sections of radial shaft seals, a lot of them are very, very similar and all look alike. All are not alike, because that design of that cross section of that seal, along with the material, has a significant effect on the pumping ability of the seal and the load on the shaft. And if you minimize that load and maximize your pumping ability, you will minimize the friction. And we've actually done testing at 3 different temperature levels, and that has contributed to some different friction type of curves here. We've gone from 0 RPM to 6,000 RPMs with these types of tests. And a significant thing to see here is that of all 4 of these seals, the Freudenberg seal is the blue seal, the blue colored graph line, and it is the lowest. So of our competitors, we have demonstrated in internal testing that we have the lowest frictional torque of standard seal designs. Now, what that does is, again, we talked about heat. We're minimizing that as opposed to our competitors. We have proprietary materials and cross-sectional designs that will have higher resistance to the temperature and the wear resistance. And what we've demonstrated, we have a robust design that, depending upon the temperature, would be 20 to 55% less friction than our competitor's standard design. And again, whenever we can lower the temperature, lower the thermal impact on the system, everything lives longer. The seals, the shafts, everything lives longer, even the lubricate. So we're going to take a look at 3 different areas that we feel that we can help the gearbox industry. And one of those is using a rubber outer diameter. We do offer metal outer diameters on our seal, but we do offer quite a bit of rubber diameters, and we actually prefer that. And some of the challenges that it addresses is we have temperature. We have cycling temperatures going on in the application. We have maybe some dissimilar metals going on. We might have a steel bore or a cast iron bore or an aluminum bore. The rubber can compensate for that, all of the different thermal activities, because its thermal coefficient expansion is much greater than any sort of bore material that we could have. And the other challenge is the perception and the need for an outer diameter sealant to provide a good static seal on the outer diameter. And with a rubber outer diameter, you get that integrated directly into the seal. So the benefits of switching to a rubber outer diameter is we have improved static sealing at the outer diameter. We've basically taken a rubber static seal and placed it within the bore. This is a rubber outer diameter is used in areas where there's higher pressures, where we have hydraulic motors, hydraulic pumps, where they have a lot of pressure inside, and it's preferred because it prevents any sort of leakage, any sort of that lubricant being forced in between the bore and the OD from the pressure. We have better bore diameter tolerance, so we can have higher tolerances on the bore. We can have higher tolerances on the surface finish of the bore because the rubber will accommodate that and flex and be able to be elastic and be able to accommodate those things. Better conformability with shaft to bore misalignment, again, because we have that flexibility. It's a more forgiving seal. It's a more forgiving seal on the installation as well. And it's applicable even on two-piece housings. So we've had a lot of success with this in all of our radial shaft seal applications, ranging from engine to transmission to axle, and then in the industrial world, hydraulic pumps and motors, and gearboxes as well. Now, what's the value to you? I mean, what does this get you? Well, it can improve the OD seal, the static seal in both hot and cold conditions, because of the thermal expansion is so great within the rubber. It can compensate for any sort of heat and cold. And there is no need to glue the seal or glue the outer diameter of the seal within the bore, because it will be retained in there. We don't have to add a second. It's added onto metal ODs because it's sealant's placed there so it can provide a better static seal than just a metal to metal fit. And that's what a rubber OD will improve upon. You will not have the metal to metal fit. And that also helps you when you have actual servicing that you need to do. If you have a bore coat on your seal OD and you go into the field and you're going to do some repairs, there's just that much, it's going to be very difficult to get that bore or get that seal out of the bore, and then you're going to have some cleanup efforts in order to clean that bore up to be able to accept a new seal. Seal retention, I know, is a concern within the field. I know historically that here in North America, at least, we've had gearbox manufacturers that prefer and use metal OD, and some of the apprehension is based upon retention. They feel that rubber doesn't retain as well. We've done some retention tests on rubber OD seals to just see how well they do retain. They remain within the bore. And what we've done is we install it into the bore, we apply a pressure on the backside, and in our worst case scenario, what we found was that it would push out of the bore at about 1 bar or 14 psi. But on average, much higher, 4 times that, 4 bar or 56 psi. So now, okay, is that less than what a metal OD would be? It is, but is it adequate? Is it sufficient for your application? It absolutely is, because most of these gearboxes are vented to the atmosphere, and the maximum pressures that you see within the gearbox itself is maybe 5 psi, maybe up to 7 psi, which is it's half of what our worst case scenario was. So based on this, we feel there is a low risk for a seal blowout due to pressurization, because we're not seeing much pressurization at all. As long as the recommended bore tolerances and surface roughnesses are considered and held within the application, our Simmerring seals with a rubber OD can be used without an incident. If we have increased pressure within the system, okay, if we're going to 15 psi, 30 psi, if we have an instance where we have an application for that, we can certainly add a retention feature for that in order to retain seal within the bore. Another innovation that we have is we call our modular sealing solution design. And why do we call it a modular sealing solution? Well, it's we're taking a standard Simmerring type of design here, and with the garter spring and the rubber OD. And when we're putting an element inboard of that, which is a low friction element on the inside that actually protects that main sealing lip. It's used, a modular sealing system is used when you have high internal contamination or if you have a vertical shaft. So what we have is a lot of internal contamination due to either a vertical shaft, or if we have some lubrication that's having some reactions and is building up at the main seal lip, what we can do is we can prevent that from getting to the main seal lip. So if we have space limitations, we're not using the same seal back to back, we have this nice solution, and we minimize the friction here on the inboard side. So in some cases, especially for a painting robot here, we do have instances of high acceleration, and because we don't have a spring-loaded seal on the inboard side here, we minimize the friction. Right, so this is a 2-seal system and 1 seal. We can offer it for basically in your current space envelope, and it has lower friction and power loss than 2 seals. And because of that, it reduces the shaft wear, as well as reducing shaft wear because it is expelling any sort of internal contamination that we may have. Now, we've actually had a customer that's used this solution, and what we found is that the field tested for 20,000 hours or more with no leakage detected, and it addressed an issue that they had. So what we're going to do is we're going to see a video here. It just kind of shows you pictorially or in a video sense of what this modular sealing solution can do. So what we're going to see first is a vertical shaft. And obviously in gearboxes, we have gears meshing, we have friction, we have particles that are being produced. So we're going to have internal contaminants. And if we have a vertical shaft, we have a tendency to where if those contaminants, those flakes of metal particles are flaked off and they make their way down to the sealing area, they have no way to be expelled, right? So they sit here, they build up there, and we have sharp edges of these metal particles packing in there. And then what it can do is it can wear the rubber. You can see it wearing the rubber and actually wearing the shaft as well. And then over time, what you're going to have is creating a leak path. So our solution is to say, how do we protect this main seal lip? How do we do that? How do we keep these particles from coming and contacting it and damaging it? So here we have our modular sealing solution. We have the main sealing element down here with the spring, and then we have the sine element up at the top. And because we have a sine wave molded into it, it's minimal friction, but it also gives a type of feature in the rotation that as the particles ride with the shaft, then they get expelled away from the rubber lip area. So for critical lubricants, that's another area that can create some internal contamination. We have high additives for anti-wear, lower friction, longer life. And in some cases, because of the temperatures within the gearbox themselves, we can have deposits being built up on the shaft. And we have the same sort of challenges, right? If they build up on the shaft right there in the seal area, they pack in, it can do 2 different things. Number 1, it can damage the seal. Number 2, it can keep the lubricant from actually feeding to the shaft seal, which is what we need. We need some of that lubricant. And if that's not there, what will happen is it will basically run dry, and you'll see this sort of damage again to the seal lip and to the shaft. So in this case, again, we are dealing with internal contaminants. We place the MSS1, we have a sine wave molded onto the lip of the internal element, and again, as the contaminants start to build up, they actually get pulsed and pushed away, and maybe even dissipated before they even get built up. But this allows oil to feed to that main seal lip, and it prevents the damage from occurring, so it protects it from getting there. Some of our features and benefits here for the modular sealing solution. So one of our others, this is the last one we'll talk about, is our premium sine seal. And essentially what we've done is we've taken the principle from the MSS1, that inboard seal with the sine wave molded into the lip instead of a sprung seal. What we've done is created a lower friction, longer life seal using that sine pattern, right? So our challenges in a high-end gearbox manufacturer, again, we're talking about friction, we're talking about lifetime. We want to reduce the friction, so we want to extend the lifetime, extend the warranty period, the servicing intervals. So we've offered this PSS solution, premium sine seal. It's molded rubber. It has a sine wave on the inner lip here, and no grease is required, no spring is required. But what it does is can operate in high rotational speeds, temperature range basically of FKM. That's what we use because we want to minimize the heat, and we want to be able to minimize the heat because of the design and also be resistant to heat during the application. So it handles high switching frequencies. So this is a bi-directional seal. You can have high accelerations going in the forward and reverse direction. And what we found with this specific customer is that the use of going from a typical sprung seal to a PSS seal, we reduced the wear on the sealing lick by up to 50%, and that we measured that basically on in-house testing and measuring of the wear band before and after testing. And the expected service life, we increased it from 10,000 hours to actually 20,000 hours. So going back to the tribological system, this is where I guess no pun intended, the rubber meets the road. This is the importance of the entire system, which is the rubber, the seal, the shaft, and the lubricant, and how those interact. And as I mentioned, we have a deep knowledge of that, and our engineering services offers that deep knowledge and investigative type of skills that we have and capabilities to you in the form of both modeling at the design stage. If you have a new project or you're trying to improve upon a current project, we have simulation, FEA simulations. We characterize our own materials and able to give you a very good indication of how parts will perform. We even use that internally to understand it and be sure that we can mold the parts effectively without damaging them when we're demolding them. And we also have quite a bit of testing capabilities in-house, our own test rigs, whether we're testing the actual component part or whether we're testing a unit. We have the ability to test hydraulic motor units, and depending on the size of the gearbox unit, we could even have the potential to be able to do that. So we can vary many things from the speed, from the frequency of the speed of the shaft, the temperature, high temperature, low temperature, eccentricity, dust, things of that nature. We also offer quite a bit of analytics, we analyze the shaft, we can analyze the actual Simmerring seal itself, and we can analyze the lubricant. So those are the three key areas of the tribological system that we can assist. And especially from the shaft standpoint, we found over the course of our entire seal career that probably 60 to 65%, roughly in that range, of seal leakage actually comes from seal installation damage or shaft damage. And we have new topographical tools now to where we can evaluate things such as macro lead and micro lead wear and deposits, where in the past, you use the horsehair method or some other method to try to determine the lead on the shaft, and oftentimes it's very difficult to determine if lead exists or not. These types of methods now, we can get to much deeper levels of understanding shaft topography and determine if we even have micro lead or something that's contributing to that sort of leakage. But all of these services are available for specific projects or problems or issues. So we've talked a lot about how seals work and some innovations that we have, but we do have, it's all part of our standard part portfolio. So we do have two different areas, two different buckets we can offer, right? We have a standard catalog part portfolio where you actually see some of what we talked about here today. We have MSS1s in the catalog available, we have PSS available, and these other standard profiles as well. We even have metal OD. Don't think that we can't support you with a metal OD, because we can. But we have quite an extensive catalog program. Over 8,000 items are available. We can package them in industrial pack, which is more parts per package, and also small pack, which depending on the size of the part can be one part that we pack one each, or up to 5, or whatever. Dimensions range from 4 to 820 millimeters in shaft diameter, and these use standard processes. They use standard molding processes, standard materials, and as our custom seal line. We can also offer you customized Simmerrings, whether that's from a clean sheet of paper from the ground up, understanding your application, and then based upon the parameters of your application, coming up with the appropriate material, the appropriate seal design. That's something we can offer as a custom basis, but we can also modify our catalog designs to get us, it bridges the gap between, okay, the catalog seal isn't quite what we need a little tweak, but we don't want to go all the way into a custom type of application. This is a great way to do it. So we have different ways we can do that, and here's some examples of that. For speed, if we have a high speed, we can vent the dust slit so that we don't pull a vacuum between the main lip here and the dust slit. That happens if we get too high of a speed. Modified spring, we can lessen the spring load if we have, if we have higher speeds or we have some vibration, we can lessen that spring load if we need to. We analyze it and determine that's what's needed. Dirt impact, fine dirt, dry dirt impact. We have a non-woven division. Basically, it's not felt, but it's a felt-like material. It's a non-woven material. It's a breathable material, right? So basically we're gluing this to the back end of the seal. It becomes a filter. It becomes an air filter, essentially, because since the seal is a one-way pump, as we pump oil under lip and back, we actually are pulling air in under the seal lip from the outside. So that's why it's so important to keep outside contamination to a minimum, because we can pull that under the lip. So this non-woven disc is basically an air filter. If we get into media that's both dirt, maybe muddy, or has some moisture content to it, then we change this disc that we can place on the back to a PTFE disc, and that'll give us better contamination exclusion. And also for media, we can pre-grease the dust lip, because actually by putting grease between those lips, it helps when you're installing the seal and initial startup lubrication, but it also provides an extra barrier for dirt and contaminants to have to get through in order to get to the main lip. So now that we've talked about all these things, you're going to be like, how can I learn more about these? And you can certainly do that on our website. We have 3 areas that basically you can look into. One is our most basic here. It's our e-catalog, searchable database of over 14,000 seals and technical details. We have data sheets in there that you can understand, material data sheet, that specific design, a data sheet on that, and also information on the minimum order quantities and the weight and the country of origin. If you're not sure exactly what you need, from the e-catalog, we can use, within the e-catalog, you can use the Simmerring selector. And this is something that, based upon the input and your criteria, whether it's size, whether it's temperature, whether it's media you're trying to seal, or even if you have the part number of a competitor offering, this selector can help you find the seal, either cross-reference it to one of our seals, or give you a listing or an output of possible seals from our catalog that are applicable and that will be perform in your application. And then also within there, if we have an e-commerce platform, which is our easy, we call it our easy ordering platform. And that's the quickest way to get a hold of standard catalog product offerings that you find within the e-catalog on your own or through the use of the Simmerring selector. So in summary, we're here today to talk about leveraging Simmerring seals for better performance of your gearboxes. And we talked about many things, but many specific things. But I basically really want to start really from the right-hand side of this slide and come to the left is, why should you be looking at Freudenberg and OK? But we have designs and designed for optimum performance and durability with our materials, with our cross sections. We've shown how our cross sections and materials of our steels minimize the friction compared to our competitors, and that is available in our standard catalog seals. And because of that, because we're reducing the heat and the thermal impact, it's crafted for extended warranty, and it increases the longevity and efficiency of your systems. We are at the forefront of sealing innovation. As mentioned, we invest a lot of our revenue back into R&D activities and in developing actual products and materials that are in the market for the past 4 to 5 years, significantly impacting performance in the market. We have global R&D teams focused on material chemistry for design and innovation, and we have a lot of testing capability and have performed many tests, over 100,000 hours of tests on oil seal designs during the course of our history. We have localized design engineering and dynamic testing services. So we offer technical support and testing in your region, or if not, we can certainly leverage our global footprint in order to support you with that. We offer diagnostic support for shaft, seal, and lubrication issues, whether that's merely on site, helping you understand maybe best practices of how to assemble your seals, all the way to returning failed seals and shafts to us to do an initial evaluation, which could then even lead into maybe a test sort of program in order to understand better and duplicate what's going on to get a better solution there. And then we have global localized manufacturing. We are a global footprint company. We have the ability to provide local for local product and production there. We're vertically integrated, so we're very much aligned both locally and globally to be self-sufficient from the materials through the design, through the molding process and manufacturing process. And we do have warehouses globally in the 3 regions we mentioned, and we can stock product for you local there as well. So with that, that's the end of what I had to say for this webinar. And if you have any questions, now is the time. I'd be happy to answer them.
Thanks, Darren. What a fascinating story, Freudenberg, and the amount of money and resources that have been invested into these seal solutions. It's really incredible. So we have with us Victoria Motard from Freudenberg, and Victoria is going to help us out with fielding some questions. Victoria, are you there? You have a first question you want to present to Darren?
Hi, everyone. Yeah, we have a couple of really good questions that came in from our guests here. So we'll start off with one of the we'll start off with a softball, Darren. What are the different surface finish requirements for rubber versus metal OD seals?
Well, they are different. I don't have them specifically here in front of me, but I can tell you that a metal surface finish for a metal OD part is going to be tighter. You're going to have a tighter specification for surface finish on your board than what you would need from using a rubber OD.
Okay. Let's see. For our next question, what special considerations are required for applications where the shaft being sealed is constantly reversing, accelerating, and deaccelerating, like say 15 seconds cycle time.
What special consideration? Well, what comes to mind initially is that we would really need to consider reducing the friction and increasing the thermal performance of the seal. Because when you have stopping and starting, you have the potential for stiction on the stopping and starting, which could damage the seal over time. But the biggest thing is we have these very high temperature gradients where you're coming down to not very much temperature, and then it's quickly accelerating and you're having a lot of temperature. So you're putting a lot of heat history into your seal. So we definitely would need to consider both a lower friction seal and one with a high performing thermal material. And Victoria, I just want to go back to our original question about the recommended housing surface finish. I was able to locate something very quickly. Just in general, with a metal OD seal, our max roughness on the bore would be 100 microinches RA. And with a rubber OD seal, that max bore roughness can increase to 150 microinches RA.
Thank you for that, Darren. Let's see, we've got a whole bunch of questions that have come in. Let's see.
Darren, while Victoria's getting organized there, could you answer this one? If a customer wants to order, like say 100 seals or 200 seals, how long does it take for you to get an order together? Do you have to go into manufacturing, or are these parts all ready to ship?
That's a good question, Gary. And I guess the answer to that is yes and no. It certainly depends upon the part. And while we have 8,000 parts, available and tooled and able to be made, we don't have all of those parts available on the shelf just because of past order history and the frequency of use. So it's very part dependent upon which one is available and which one you'd have to wait and get into the manufacturing queue. One of the great things in the e-catalog feature is that it will show you as well, I believe, if there's any available stock of that specific part number or not.
So is there a typical length of time in the queue to produce something like that?
Again, that is part dependent, but I can say as a rule of thumb, you're probably looking a manufacturing queue maybe 10 to 14 weeks, roughly, depending upon the part.
Okay, so a lot of times it's a good idea to anticipate that you want to get your orders in, a couple of months or more in advance, right? To be able to meet the demand or meet your requirements or the individual's requirements, rather.
Certainly, the more visibility you have and more visibility that you can provide to us is definitely beneficial in order for us to get the order into the system and get it into the queue. The other thing that we examine and investigate is if you know that you have an annual demand or you have a reoccurring demand that's pretty consistent, we can certainly look into blanket orders. And if we are able to see a blanket order, then we can possibly look into understanding what your typical annual use is, and then maybe pull in some safety stock in order to keep that pipeline full.
Great, thank you. Victoria, back to you.
Okay, we're getting a lot of questions about how can I get in contact with my local salesperson or find out if there's a dealer or distributor in my area. One of the key things I would recommend, sorry to steal your thunder, Darren, would be to scan that QR code. And what it's going to do is it's going to send you directly to the radial shaft seal page on FST.com. And from there, there's going to be a contact page down at the bottom. And if you fill out that information, primarily country is one of the biggest factors there, and in region, we should be able to get somebody from sales or get you your technical support from the contacts from your region. So that's that's a good point. That was a very good question that a few people had. Let's see.
Yeah, thanks for reminding us. So, as Victoria said, you take your phone and hold it up to the screen here in the video, and your phone will actually capture that code that's right in front of you. That's called a QR code. And that QR code will link you right in through your browser from your phone into the FST page. We also will include that link right there in the follow-up email so that you can use that as well. And that on the screen there in this slide, Darren, that's actually what the contact form looks like on the bottom of the page, right?
That's correct, Gary.
All right, thanks. Go ahead then, Victoria.
There's still a lot of questions. There's still some question involving shaft tolerance still, Darren.
Tolerance, okay.
Okay. So is there a standard available? I think you answered that one. Then there's questions about storing of the seals,
Okay.
particularly NBR seals.
I'm sorry, particularly what kind of seals?
NBR seals.
Okay. NBR seals, the typical storage time for NBR seals is 7 years, and FKM can be up to 10 years. One thing to keep in mind, though, is if these are pre-greased, the grease lowers, regardless of what the rubber material is, the grease lowers the shelf life down to a total of 3 years. But this is what we tell people, you know, that's a recommendation. As long as you store the seals in its packaging, minimize its exposure to any type of light, whether it's sunlight, whether it's UV light, that will react with the surface of the rubber, and that can start to age it. So our rule of thumb is we recommend the appropriate shelf life depending upon the industry specification. But the other thing we recommend too is, like, if you get to that point of having it being that long, examine it, see if there's surface cracks on it, or see if it feels stiffer than it should, or it's very stiff and brittle. Then yeah, we shouldn't be using that. But if it still looks like a brand new seal and still feels and looks proper, it's probably okay to use, because that's an indication it's been stored very, very well.
Okay. I have another question, which is one, it's one of the frequently asked questions that we get is, what is the difference between a BA and a BAUM?
Okay. There's really no difference in the sealing function or sealing technology of a BA or a BAUM. A BA is a designation for a rubber OD, right? A BA and a single lip, so there's no dust lip, it's just a single sprung lip. Where the UM comes into play is you know, it's a more recent technology. It's a more recent molding process and molding technology. It gives a slightly different cross section, but it gives the same functionality.
So, Darren, what's like some of the more extreme applications out there that your company has worked on? You know, we hear a lot about seals with rocket ships, or maybe wind power generators and that type of thing, as well as, like, on the other end of things, the really small gearboxes. What are you guys capable of?
It's funny you should ask that. We're actually involved in all of the industries that you just mentioned. You know, we're involved in very large wind turbines, in sealing motors that go into wind turbines, actually sealing the actual blades, the pitch and yaw directional mechanisms within the blades, within the wind turbine. And we also go all the way down. We are making parts that go into electric toothbrushes. That's how far down in diameter and how small parts that we can make.
Amazing. That's really great. Victoria, how are we doing? Do we have maybe time for one more, do you think?
Maybe one more. There's a follow-up question on the surface finish, Darren. Sure. Basically, is there a minimum surface finish recommendation for rubber OD? I've seen rubber OD seals blow out of retainers where metal ODs work well for a finer finish.
Yes, I'm looking here to see what I have in front of me right now. I do not have a minimum. I'm sorry, I don't have it right there. I'm sure there is. I'm sure there is, because just like with the shaft finish, you can get a shaft finish too smooth. I mean, a lot of people think that a smoother shaft is works better with the shaft seal. That's not the case. There is a nice sweet spot between minimum and maximum. Unfortunately, I just don't have that right in front of me right now.
No worries. Well, I think it's a good time to wrap things up. And, you know, folks, if you do have these questions, go ahead and send them into Darren and Freudenberg through that contact form that we showed. Darren, would you mind going back to that QR code, our last
Sure.
slide? All right, so this is what we're talking about. This is the QR code here to go ahead and scan that with your phone, fill in the form here with your specific questions, and we'll tackle them there. So it's time for us to go today. Thanks very much, Darren. And as you can see, gear technology performs better with Freudenberg NOK seals, their vast catalog and manufacturing capabilities. And thanks to all 120 or more attendees here today. It was really a pleasure to be able to host this for you. Just a reminder, a replay of the presentation will be available for on-demand viewing by tomorrow on the website. And we'll be sending out an email to all attendees and those who registered, and it'll have links in it, which you are welcome to share with your colleagues. So on behalf of Freudenberg NOK Gear Technology, thanks very much for your participation. Victoria, I appreciate your help. And Darren, thanks much. You did a great job today.
Thanks for that, Gary. And thanks everyone for your attendance and your questions, and have a great rest of your week.
Thank you, folks. Have a great day today.